Okay, I'm going to use this time to drum up some support, love, enthusiasm, criticism, hate, whatever you have in you for a new proposal that I just submitted to the issue tracker at 3 o'clock this afternoon. And it's about alias declarations for Go. So if you're interested, please have a look. Think about it. Send me your feedback. It may change your life or not, depending on the kind of life you have. So here a little bit about the motivation. So let's suppose you have a package L and a client. And that client C imports your package L. Now, you're going to make a change in this package L. You want to refactor it. You make it bigger. You want to do some cleanups. And you got a package L and L1. And some stuff that was before in L is now in L1. Now, in order for C to continue to work, you have to update that package C as well. And it has to refer to L and L1 at this point. And you have to make that change at the same time, because if you don't do it, then you break the build. Not a big deal. Now, let's say you have the same package L, but you have a lot of clients, say 100, or maybe hundreds, or maybe even 1,000. And now you're going to refactor this L into L and L1 again, and some stuff that's now in L is now in L1. Now you actually have to update all these packages, client packages, simultaneously, because if you don't do, then you broke the continuous build. And that's an actual real problem if you have a large software organization and where you potentially not are under control of all these clients. Some of them have been written by other people. Some change at different rates, and you don't want to break the build. Another example is you are a company. You are actually providing a package that other people are using, and you want to evolve that package, and there's a similar situation. You cannot update all the clients. So you want to keep the clients working. So how can you solve this problem? One way to do this is to make this update incremental. So if you could go and just change 1 or 2 of those packages that are clients, or maybe a whole bunch of them at one time, then you can go about this over a period of time, and you're not going to break the build. And so that would be pretty easy to do if you could leave some kind of a forwarding declaration in one of those in the package L that would allow you to your clients to continue to refer to this L, but actually start using the new package. But can we do this? Now, it turns out this is pretty easy for constants and functions. So let's say you have this package L, and you now factored out some stuff into package L1. You can keep an import to L1 in L. And for constants and functions, you can have a forward declaration, so to speak, here. Let me see that. Show that here. So for a constant, you can just define a new constant that has the same name as the one that you just moved. For functions, you can have some wrapper functions that are calling the function that you moved, or you can even declare a variable of function type if you don't worry about or don't have to worry about the function, that variable being overwritten. It's not so easy for variables. There is a way, and it's a bit complicated. Here you have to go a different route. You have to introduce a pointer to the original variable in the new package L1. Then you can start incrementally update all these clients to start using this pointer to that variable. Then you can move the original variable to L1, and then you can, in the second round, update the clients again to use the original variable that's now moved, and then you can start removing that pointer variable again. And it's pretty tricky because if you don't do this in the right order, if you move some stuff first from L to L1, before you move the variables, then you get to cyclic imports. Because in order to do this, you have to import L in L1, but in order to move some other things forward from L to L1, you have to import L1 in L. So it's a nasty problem. This is not possible at all to do for types. If you do a regular type declaration, as you see here, T is actually a new type. It's not the same type as L1. And T has no method. So there is actually no workaround for types. So how do you go about this? What we would really like to do is have some form of an alias declaration which basically says this is the same thing as this. It just has a different name. And borrowing from the constant notation, it would be nice if we could do something like this for all objects that we have in a package, constants, types, variables, and functions. And it almost works, except for variables, where this notation, this syntax already has a different meaning. So Rob Pike and I sat down together and thought a little bit about this, and there's an easy solution. We introduce a new token, which is the right arrow. And this is essentially the essence of the proposal. There's a new kind of declaration which allows us to declare an alternative name for something that's on the right-hand side, which is usually a qualified identifier that is a package followed by a name. This would allow you to say, this T is really L1.T. And the same rules would apply as for any other declaration. So you can export this thing, you can leave it inside, and so forth. There's a bunch of rules. I'm not going to go into them. Here's a bunch of examples. So you might use this for shortcuts. You might use this for actual forwarding declarations to address this problem that I mentioned in the beginning. You can group them because they're just parts of declarations. You cannot use them to have shortcuts for some bigger item that is not just the qualified name. And you may even potentially use it to shortcut very long names. So there's some very minimal syntax changes that I will publish, and there's a bunch of consequences. Compiler needs to be updated. There's probably some libraries that process Go code that need to be updated. And there's, of course, new opportunities for misuse. So there's a bunch of unknowns. We don't know about them. And that's why I sent this out to the general public. I'd like you to have a look at this and think about it hard. Details are at this new issue, 1633.9. Send me your thoughts. Thank you very much.